All right, everybody. So now we're looking at 9.2.2. What is special about a right triangle? Now, remember, when we're talking about right triangles, that is a triangle that has a right angle in it. All right. So here we've got our 90 degree, our right angle. And so those are the types of triangles that we're going to be looking at. Now, when we're talking about a right triangle, it could be this way as well. All right. It could also be this way as well. It doesn't have to be standing straight up like we see in this example. All right, but that's what you'll most commonly see as we go through some of these problems. So here we're looking at the Pythagorean theorem, and maybe you've heard of it before. All right, and here it says in lesson 9.2.1, you saw that for three lengths to form a triangle, they must be related to each other in a very special way. And today you will investigate a special relationship between the side lengths of a right triangle. This relationship will allow us to find the length of a missing side for a right triangle. All right, so let's dive right into it. We've got 9-68. Use your patterns from lesson 9.2.1 to decide if the squares listed below will form a right triangle. Okay, so I go over to my 9.2.1C resource page, which helped me keep track of the different triangles I created with the square and helped me notice some patterns between the area of the small square plus the area of the medium square and how it related to the area of the largest square. So for example, if I had the side lengths of 3, 4, and 5, I'm going to go ahead and draw that out here down below. So I had 3, 4, and 5. When I took the area of the small square, meaning I created a square here that was 3 by 3, that area was 9. All right, and so hopefully that jogs some memories from yesterday. We've got 9 plus 16, that gave us 25. Then we compared it to the area of the largest length, all right, or the largest square. And since the area of the two medium squares was equal to the area of the largest square, then it created a right triangle. So that's what we know it has to be today. A squared plus B squared equals C squared. The area of my first two triangles added together has to equal the area of my largest square. So let's go ahead and try it out. 6 squared plus 8 squared, does it equal 10 squared? Well, we've got 36 plus 64. Does that equal 100? My goodness, I think it does. All right, so that'd be the first problem there. And you could draw some diagrams to help you out. For example, in this next one, instead of writing it out like this, it's giving me what the square value is. So imagine I have a triangle created and I'm using the squares 64, 100, and finally 144. Is that going to allow me to create a right triangle when I put these together just like I did yesterday for our activity? Same with C. And then finally, looking at D, explain how you know whether three squares will join at their corners to form a right triangle. All right, so think about the relationship here that we looked at on our resource page from yesterday. How do you know if it's going to form a right triangle or not? All right, now we're moving on to 9-69, the Pythagorean relationship. So based on your work so far, if you know the area of three squares, you can tell if they will connect at their corners to form a right triangle. But what if you know that a triangle has a right angle? For example, we look down here in this problem and it tells us this triangle has a right angle. Will the lengths of the sides be related in this way? We're going to work with our teammates to look more closely at the side length of some right triangles. All right, so what you're going to do is grab some centimeter graph paper, if you have some. Now, if you don't, and you're just using the graphing notebooks that we have, then it's not going to be a centimeter by a centimeter. And so what you're going to do is actually start measuring without using a ruler. And instead, you're going to use more graph paper to measure. In other words, I could take this graph paper and put it over the top of my other graph paper to measure it. And I could rotate it. I could turn it diagonally. And so that's what we're going to have to do here. says form a right angle by drawing one 5 centimeter length and one 12 centimeter length as shown at right. So here it is. After drawing the two lengths, create a right triangle by connecting the ends of the two lengths with a third side. Okay, so I'm going to grab my ruler so that way it's a nice straight line, and I'm going to need to draw 12 across. So here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then I have to go 5 up. So I want to go 90 degrees here, so it's a straight line. And I got to draw 5 up. 1, 2, 3, 4, 5. Okay, now I can label my sides appropriately. We've got our 12 centimeters and we've got our 5 centimeters. So now it's saying if we connect a straight line here, so I'm going to use my ruler tool again. What is the distance of that third side? Right now it's unknown. So what you're going to do here is take your graph paper, as I said before, and you are going to turn it diagonally. I can't do it on this app, but if I could, I would turn it diagonally, and I would measure what that side length is.